Assalamualaikum warahmatullahi wabarakatuh. So this is example 4 for conservation of AC power. So 3 questions referring to this circuit. Find the average power and reactive power supplied by the source. So the solution is, I think, very straightforward. Okay. Very thick. So I need to. Okay, so for the solutions, so I think it's better for us. Okay, so please be understood that if the value is not given as a RMS, so we treat this value of the voltage as Vm. Okay, Vm, unless it's stated this is RMS value. Okay, so this is 5 volt, which is your Vm, V maximum. So what you need to do is actually to find out what is the total current of the circuit, which is the impedance is 4 negative J2 ohm. Okay, so very straightforward. So I, by using V over Z, is actually V 30 degrees, and your Z is 4 minus J2, which is will give you the answer is 1.12 with an angle of 56.5 ampere. Okay, so the average power and reactive power supplied by the source. So we can actually calculate what is the complex power, because we already know that the complex power, okay, for the source, okay, the complex power has all the information of the total power inside the circuit. Okay, so complex power for the source, which is S, still S, so 1 over 2 Vm Im conjugate. So this one is Vm is given as a 5 when an angle of 30 degrees multiplied with the I conjugate 1.12 negative 56.5, which will give you the answer of 2.5 minus J 1.25 VA. Okay, so the average power supplied by the source is 2.5 watt. Q by the source is negative 1.25 bar. Okay, and then the second questions. So this is the first questions. So the second question is find the average power absorbed by the resistor. So from this circuit, okay, we have only one element resistor, okay, one element of the resistor, and we should know that only resistor absorb average power. Okay, so meaning that all the average power supplied by the source is equal to the average power that absorbed by the 4 resistor, which is 2.5 watt. Okay. Next is to find the source power factor. So the source power factor can be obtained from the complex power, which is you have already calculated 2.5 minus j to 1.25, but we need to convert into the polar form to get, okay? So minus 1.25 I, then convert into a rectangle polar form. So you should get the answer, sorry, the complex power is 2.795 with an angle of negative 26.5. Okay, so the power factor is actually a cos of negative 26.5, which is will give you 0.89, but it didn't mention whether it is leading or lagging. Okay, but you should know that based on the complex power that has been calculated earlier here, this is your complex power, we should know that for negative Q, okay, so negative Q meaning that it is capacitive. Okay, so for a capacitive, the power factor should be leading. Okay, so that is example 4. Already saw for example 4.